So as the next example, so let us take the function y is equal to mod x by x, and let us try to find the value of limit x tends to 0 mod x by x. So this is the function for which I want to find the limit. Now what do you know, what do you understand about this function y is equal to mod x by x? So if you try to write it in piecewise fashion, so we know that mod x is equal to plus x if x is greater than 0, and mod x is equal to minus x if x is less than 0. So y is equal to x by x if x is greater than 0, and minus x by x if x is less than 0. And when x is equal to 0, you're getting 0 by 0. That means the function is not defined at x is equal to 0. So not defined at x is equal to 0. So x by x, as you know, is 1. Because x is not equal to 0, I can cancel these two. Here also x is not equal to 0, I can cancel these two. So 1 if x is greater than 0, minus 1 if x is less than 0, undefined if x is equal to 0. Now if you draw the graph of this function, it looks something like this. So when x is greater than 0, the functional value is plus 1. When x is less than 0, the functional value is minus 1. And at x is equal to 0, the function is not defined. That is, this plus 1 works till x is equal to 0. So you have a hollow dot here. So you need to have hollow dot here. Means this graph works closer and closer to 0, but not at x is equal to 0. So here also I need to have a hollow dot, because this y equal to minus 1 is valid only till 0 but not at 0. And at x is equal to 0, the function is not defined. So if I ask you to find limit x tends to 0, so what you first need to do is, you need to find the right hand limit. That is, what is happening to this function in the positive neighborhood of 0. So this is exactly x is equal to 0. As x approaches 0 from the right hand side, as you can see, the value of y is always equal to plus 1. So as x tends to 0, you don't need to find what is happening exactly at 0. So exactly at 0 it is undefined, but within the positive neighborhood of 0, the functional value is equal to 1. So limit x tends to 0 plus f of x is equal to 1. And limit x tends to 0 minus, what is f of x? So if you go from the negative neighborhood of 0, as you can see, the values of y are tending to minus 1, right? Tending to minus 1. So line x tends to 0 minus f of x is minus 1. So here also the right limit is not same as left limit. So the left hand limit LHL, left hand limit, is not equal to RHL, right hand limit. So this implies limit x tends to 0, f of x or mod x by x does not exist. Limit x tends to 0, f of x does not exist. So now, as the fourth example, let us take this function. Let f of x is equal to x square minus 4 by x minus 2. You are asked to find limit x tends to 2 f of x. So as you can clearly see, what is f of 2? F of 2 is 4 minus 4, 0 by 2 minus 2, 0. So f of 2 is equal to 0. Hence, the functional value at x is equal to 2 does not exist. But you are not being asked to find a functional value at x is equal to 2. You are being asked to find the limit at x is equal to 2. That is, as x gets closer and closer to 2, where does f of x tend to? So now let us try to write this function in a piecewise manner. So f of x is equal to, so at x is equal to 2, it is not defined. When x is not equal to 2, what does this function become? So x square minus 4 is x plus 2 times x minus 2 by x minus 2. So I can cancel these two as long as x is not equal to 2. That means the function is f of x is equal to x plus 2 as long as x is not equal to 2. And undefined at x is equal to 2. So how does the graph of this look like? How does the graph of this look like? This graph is exactly same as the graph of x plus 2. So y is equal to x plus 2, something like this. But the difference is y equal to x plus 2 is valid at all points except at x is equal to 2. When at x is equal to 2, this graph is not valid. Exactly at x is equal to 2, this function is undefined. At all other points, this graph works. That means exactly at x is equal to 2, you have a hollow dot, and then it continues. This is how the graph looks like. So what is limit x tends to 2 f of x? So let us find the left hand limit. So limit x tends to 2 minus f of x is nothing but limit x tends to 2 minus x plus 2. X tends to 2 minus x plus 2. So as you can see, as x gets closer and closer to 2, the value of f of x gets closer and closer to this value, which is equal to 4, right? So when the function is very simple, you can directly do the substitution. So as limit x tends to 2 minus x plus 2. So as x tends to 2, x plus 2 tends to 4. Similarly, what is the right hand limit? So right hand limit, limit x tends to 2 plus fx is nothing but, so on the right hand side of 2 also, as you can see, as x gets closer and closer to 2, again fx is again getting closer and closer to 4. So this value is also equal to 4. So hence right hand limit is same as left hand limit, hence limit x tends to 2 f of x is equal to 4. So this is a case when f of 2 does not exist. So f of 2 does not exist. That is, the functional value does not exist, but limit value exists. So I hope you are understanding the difference between the functional value and the value of limit, and within the calculation of limit, the right hand limit and the left hand limit. So let us try to summarize the little portion that we have covered till now. So the things that we have understood in this short introduction of limits is what is the meaning of neighborhood of A. So if you take a number line and if you have a number A, what is the neighborhood of A? A short interval surrounding A is called neighborhood of A. So I can write it as an open interval A minus h to A plus h, where h tends to 0. So if you have A, the neighborhood of A is something like A minus h to A plus h, an open interval where h is tending to 0, that is a very small number. So a very infinitesimal interval surrounding A is called the neighborhood of A. And what is the right neighborhood of A? So A comma A plus h is called the right neighborhood of A, and we usually just represent it as A plus. So A plus represents the right neighborhood of A. And what is the left neighborhood? A minus h to A. A minus h to A, this interval is called the left neighborhood of A. This is usually represented by A minus. And both right neighborhood and left neighborhood constitute the neighborhood of A. And what is limit of a function as x at x is equal to A? This is nothing but what happens to f of x as x tends to A. So there are two types of limits, right hand limit and left hand limit. So what is right hand limit? So what happens to function as x tends to a from the positive side. So limit x tends to a plus f of x is called the right hand limit. So limit x tends to a minus f of x is called the left hand limit. So sometimes right hand limit and left hand limit are different. In that case, we say that limit does not exist. And if right hand limit is same as left hand limit, then we say that the limit of a function exists and is equal to any of them, any of the two, because both are equal. And next, we have also understood the difference between the value of limit and the functional value at x is equal to a. For example, if you have a graph which is nicely continuous and this is x is equal to a, you have a smooth graph going like this. So in this, for this graph, the value of limit x tends to a fx is same as f of a. So if the graph is smooth and continuous, then the value of limit will be exactly same as the functional value. But if the graph is something like this, at x is equal to a. So this is an example of where the functional value at a does not exist, but the value of limit x tends to a exists. So here limit x tends to a fx exists, but f of a does not exist. If the graph is something like this, sometimes the graph can also be like this. So if this is what happens at x is equal to a, in this case f of a exists, but the right hand limit and the left hand limit are both different, hence limit does not exist. So limit x tends to a f of x does not exist. So both limit and f of a exist and both are same. Limit exists but f of a does not exist. F of a exists but limit does not exist. And you can also have a case like this. So at x is equal to a, f of a also does not exist and limit also does not exist. So both do not exist. So both fx, f of a and the limit both do not exist. So you can have any of these four cases in terms of limits. And this becomes very important because when the given function has a smooth graph, has no problems of undefinedness or piecewiseness, then if you want to find the limit, you can directly put x is equal to a in the function. But this can happen only if the function is nice. There are no breakages or there are no undefinedness. And if the function is piecewise defined, it is always advisable to find both the right limit and the left limit and compare it. So these are the things that we have learned in our very first topic.